Good evening, everyone. Today's class we'll be seeing about static electricity. Now, I will not go through all those details of static electricity. You can read it from the text. It's not very difficult. But then sometimes, there are some common errors that students, I've noticed many of the students, unknowingly write it and then they lose marks. So basically, I'll be concentrating on those misconceptions or, the wrong terminology that you should avoid while you're explaining static electricity, all right? Now, what is static electricity? What is the difference between static and current? Static electricity speaks about the science of charges that are at rest. Current electricity is, we'll see that in the next session. Current electricity is about the charges that are moving, all right? Now, so what is the difference between the charges at rest? Or, any atom, if you take, you have got positive charges and electrons, as you all know. So what do we mean by static electricity, the charges which are at rest? It is nothing but, if you take a neutral object, yes, you have got plus and minus, they are balanced, and they're just normal objects. But if you could make it charged by supplying some extra electrons, or if they loses electrons, if they gains electron, then you are creating an imbalance in their charges, right? We are talking about those additional charges, or if they have lost those charges, what happens to the material as a whole is what is about static electricity. Now, the simple method of making any object charged would be, everyone would immediately shout out the answer: friction. Yes, by friction, which means you can just have two objects rubbing against each other, then one may lose electron because of the force, the other one would gain electron because of which one loses, which one gains. For IGCSE, you don't have to remember all those objects that have the tendency to lose and gain. That's one advantage. All you need to know is the one which loses electron will have more positive charges compared to the negative. Say if you have like 6 positive charges in the nucleus, if it loses 1 or 2 electrons, so if you have to have a balance, you should be having 1, 2, 3, 4, 5, 6 electrons. So now it's a neutral one. If it loses 1 electron, say that gets released, what happens? The number of charges here will be, number of proton is now 6, number of electron is now 5. Am I right? So we've got 6 and 5. There is an imbalance in the charges. So this object, so we have considered one single atom. So like this, many atoms would have lost electrons. So overall, it will have more positive charges compared to the negative charges. So we call this as a positively charged ion. Now this term, as I said, is important, right? You will use ion instead of calling it as an atom. Okay, as I said earlier, the terminology, you have to be very careful. Now here we will not say a neutral atom anymore. It is going to be an ion because now the charges are not balanced. Then it is referred to as an ion. Now what if it gains electrons? Then it will have additional electron. What happens to the number of electrons now? 7. So this is greater now. So it becomes a negatively charged ion. You get it? So the charges, when they move from one object to the other, the imbalance will create not an atom anymore. It's not a neutral atom. You have to refer to it as an ion. Okay, that's tip number 1. Now second, in this, when you're explaining about or trying to describe, they might ask what happens to the charges in these particles, or in these objects. Then you should, in a solid, it is not possible for the atom as a whole to move about. I have noticed some students write the positive charged ions move to one end, the electrons move to the other side. That's like kind of a wrong usage. I'll see what I'm talking, I'll explain to you what I'm talking about. You'll understand it in a bit. Okay. This is an example of charging by friction. If you rub a balloon against a wall, it could become a negatively charged object. What happens here? The electrons have jumped off, right? The electrons have jumped off. So some of the atoms here, the neutral atoms here, have lost the electrons. Okay. you must always refer to the movement of electrons. Okay, the full form, like electrons. Why I'm insisting is that as I said in the beginning, some of the students tend to write the positive charges move, the positive ions move. That's an incorrect statement, I would say. Why is it incorrect? Because in a solid, you're not making the atoms move, because it is like, you all know about the strong force of attraction, etc., etc. So I'm not going to those details. So the friction actually removes the electrons and not as the atom as a whole. So you must refer to the movement of electrons. So the electrons get transferred from one object to the other. How does it get transferred? By charging through friction. It is due to the frictional force. That force removes some of the electrons. Okay, so the atoms which have lost the electrons from here have become positively charged ions. You get it? Two statements here. The frictional force removes the electrons from one object. In this case, the ball loses electrons, the balloon gains electrons. Now, why is it positively charged? Because the atoms that have lost the electrons have become positively charged ion. Clear? Now, the next method is about charging by induction. Okay. The next method is charging by induction. Now, the name actually itself will give you a hint. Induction, you're inducing charges in it, right? There is no contact between the two objects. Without having any contact, you can have the object charged. Now, one more important point you have to remember is about the difference between charging metals and other insulators, or conductors and insulators, because most metals are conductors. Now we'll see what is the difference there. Now this one is a metal sphere. Right. This is a metal sphere. Now, is it possible to charge or keep the charges accumulated in a metal continuously? No, because metal is a good conductor. It will allow the charges to flow through. Say, for example, you would have tried this experiment with the plastic ruler. If you rub against your hair and if you're trying to pick the chits of papers and all, it gets stuck. But if you try the same with a metal ruler, it will not get stuck. What is the reason? It's because through the metal, you can have the charges flowing through, because it is a good conductor. So you will have those electrons flowing through your body and it becomes neutral very easily. It doesn't retain the charges in a metal ruler. But in a plastic ruler, at one end when you're rubbing it, at the end where you are having the friction, you can have the charges accumulated. You can still make a metal ruler hold the charges by having an insulator covered. That's why they say, hold it with a cloth or so. Then you have to try this experiment, it will work. So metals, it will not hold the charges if it is connected to the earth or if there is any conducting path for the charges to flow through. That's one point you have to keep it in mind. So here we are trying to make a metal sphere charge. We'll see how or what are the steps involved in it and how to go about in making it charged. All right. Now the setup is such that I've got the sphere attached to an insulator. So as I said earlier, if this insulator wasn't there, if it was directly connected to the earth, what will happen? All the charges that you're trying to make it accumulate will get released. So the insulator will prevent the charges from flowing through into the earth. All right. Okay. Now I've brought a positively charged rod closer to the metal sphere. What would happen? Now in the sphere we have got some free charges. The electrons can move about freely. That's why it's a conductor. So what will happen to those electrons? They will come and accumulate on one side. Here again, you have to write about, as I said earlier, the movement of electrons, not the movement of positive charges. All right. Now those atoms that has lost these electrons will become positively charged ions. So you have got 4 electrons attracted towards the positively charged rod, and you will have the positively charged ions on the other side. Now notice that there is no contact between the two objects. What will happen if I bring it in contact with the object? That I leave it to you. You can think about it and try to get the answer. Okay. So you have an insulator. There is a gap here. You bring it closer. You have the charges separated. But if I remove this at this point in time, what will happen? It'll again come back and join because there is no force that is holding these electrons on this side. So you will have again the sphere to be neutral. So how do I permanently or have the charges accumulated? We have to think about other steps. Okay. Now what's done is keeping this positively charged rod here in position, you connect this end of the sphere to the earth. So this symbol stands for earthing wire, which means you just need to have a conducting path between the earth to this side of the metal. So what would happen, since earth is like a supplier, or it can also, take in all the electrons, you can have these electrons moving into the sphere because there is an imbalance. What will happen to these positively charged ions? They will all get neutral. So we don't represent any neutral atom in an object, only the charges we represent. So why have I removed? Because all those positively charged ions now will pick up these electrons from the earth and they become neutral. Got it? Okay. Now what do I do? Because I don't want this, I want these charges alone to be there. So I can remove this and I can remove this also. But there is one condition. Say if I remove this first. Okay, assume that I've removed the positively charged rod. Imagine what would happen. These electrons here will not be held here because there is no force to hold it. They will all get scattered, and since there is a passage here, these additional charges will flow into the earth. Again, it will become neutral. Am I right? So have we achieved our purpose? No. So what do we do instead? You keep this positively charged rod here in position so that the electrons are held here. You disconnect the earthing wire, and then now there is no passage for, because here there is insulator, there is no way the electrons could escape. So now it is safe to remove the rod. So take out the rod, right? So as I said, these additional electrons have no way to escape because air is an insulator, so it can't pass through it, and here also you have got insulator. These electrons will stay in the sphere. But will they stay like this, in this position? No. Why? Because now this is removed, so like charges, they will get repelled. So the repulsive force will make them evenly scattered. It looks like a smiley face. Okay. So it will get evenly scattered. So we have got the electrons distributed, or you have made the neutral metal sphere into a negatively charged metal sphere, which otherwise wouldn't have been possible if you had the insulator. So what are the steps involved in charging by induction? You bring a charged rod closer to the metal sphere. As I said, you think about why it shouldn't be in contact. You will have the opposite charge. Now, this is where I want you to think about. If it was a negatively charged rod brought in, you shouldn't write the positively charged ions will be, or atoms will be attracted. That's not possible because they all are held with strong forces. Only the electrons can be repelled away, right? And I'll explain that as well. So here you bring a negatively charged rod. What will happen? You cannot say the positively charged atoms will be, or ions will be attracted, because the atoms are huge. They are held with strong forces. You can only have the electrons repelled away. Say 3 electrons are repelled. Those atoms which have lost these electrons will become now ions. So those are ions now. Did you get it? Now again, you bring this. Now here what will happen? These electrons, additional electrons will flow. Not the positive charges, because again the same applies. That's why I said the key term is, or the key sentence is, movement of electrons. Keep that in mind and phrase all your sentences by connecting it to the movement of electrons. Then you will not go wrong, right? So electrons will be released. Then you can disconnect this and you can disconnect this. So you will have even distribution of positively charged ions in it. So you're making it, the sphere is now positively charged on the whole. I hope you've got some idea, or you would have realized, the mistake that you shouldn't be making while framing these statements. See you in another video.